It was like just more snow up here. We do the double whammy because it was the central location. Okay, so here's the deal. We're looking at Geometry Notes 5.1, and we're talking about mid-segment. Okay, mid-segments of a triangle is a segment connecting the midpoints of the two triangles. Okay, of two sides of a triangle, excuse me. If I'm looking at a triangle mid-segment theorem, if a segment joins the midpoint of two sides of a triangle, then the segment is parallel to the third side and half as long. So this is parallel to this, and this is half as long. So this is half of whatever AB is. Okay, that's all I'm doing. Cutting something in half or doubling something. But I'm going to have it set up so every time we do this, it's going to make sense, and you can do the same thing every time because it's a pattern. And that way you can expect to get it right as we set it up. So as we're looking at UW and VW are mid-segments of RST. UW and VW are mid-segments. Now, if I'm looking at that, I know RS is 12. Okay? And I know VW is 8. Find UW and RT based on the information you already know about mid-segments. Pretty cool to get off, huh? Yeah. How's twisting motions? A little painful? No. They're okay? Oh, okay. Well, I haven't been able to pick on you in class for it. Okay, so now, as we go through, I got this is 6, this is 6, okay, because they're half of 12. And people are like, how did you know? Notice those markings, that those were marked that they were the same. So I am showing that V is the midpoint by those marks. We also learned that VW is the mid-segment, so it connects midpoints, so that's how we knew as well. I got 8 here, and this whole side length is 16, because this is 8, and so is that. Are you okay with these measures and how I'm finding them? And remember, UW is 6, because UW was this side right here. I should have pointed that out. Didn't write that down when I talked about it. We're doing okay? You guys do example 2. See how that's working for you. Example 2. So hopefully you're starting to see, I got DE and DF are mid-segments, so D's a midpoint, E's a midpoint, F's a midpoint. That's what they told me in that information. AB is 24, so this whole thing is 24. So that means this is 12, and more importantly, DE is 12, okay? Because it is the side parallel to AB, and half as big, because it's a mid-segment across from AB. Now, if I'm looking at DF is 9, well, this is 9, this is 9, that means this bad boy is 18 as I'm going through. Are there questions regarding any of the steps I did? We're doing okay? Feeling pretty, hey, I can handle this stuff? Okay. Now, as we're going through this, I want to make sure you recognize properties. Okay, so I've got some property stuff going on. I've got AB. Now I got to find AB. I got segment AB. It should be parallel, or excuse me, well, it should be parallel to ON, but it's congruent to OC and CN. Okay, and that's what I'm looking at. You all right with those? What it should be congruent to? Go ahead and fill in the other ones they should be congruent. You guys don't have this at the bottom of yours, by the way. Go back to page 1. Go back to page 1. I have the pictures there. I don't have those blanks there. I added these blanks this morning. Okay, so this morning I drew a blank. All right. Actually, I drew a blank before, and today I filled them in, kind of. So let's go ahead and get those blanks down and those connections, and I'll double check some stuff and we'll see where we can go from there.
Review the material before you come in here to try to do that, okay? All right.
Okay, so we should be looking at these. Segment BM, segment BN, and segment A and segment OA. There's a couple people out there going, hey, Bloom, that order's funky. Don't erase your stuff. Okay, so long as you have BM or MBM, fine. And here's why. When I did this problem in this triangle, in this one, it's A to B, O to C, straight up. But A to B and really that angle and this angle are the same, B to A. Okay, so there is kind of a flip-flop in this, and it's not pure as far as congruent, but remember we kind of allowed you that adjustment during reflexive property when we flip things around during chapter 4 test, and I'm going to let that go right now. Okay, but when we're actually ordering them, you'll start recognizing congruent triangles, corresponding parts of congruent triangles will be ordered correctly as we go. In 2, I've got this going on. AB is the same as LC. AB is the same as LC. It's also the same as CK. So I got that going, and they're 5. What I want you to do is fill in the other 6 boxes, or blanks. And those should go fairly quick, I hope. Hopefully you're starting to see that AC, and I'm going to highlight these. Hopefully you're looking at the fact that we've got AC, and that's across from JK. So JB and BK are the segments that are the same measure, okay, and they're all 4. And BC, the same stuff. Are there any questions about those? Are these making sense? Now, when I'm talking about things being parallel, I know that AB is parallel to LK. Okay, it's also parallel to LC and CK, but I really look at the big long length as we're talking about this. And I say that because that's what I'm expecting you to answer next. Do 3 and 8, please. Do 3 and do 8. 3 and 8. They'll be great. To quote a great American, how you doing? Is it going okay? Yeah, for those, Joey Tribbiani, our Tribbiani moment. We doing all right on this? Are there any follow-ups? There might be an order issue, okay? Because I'm not talking about congruence. I'm okay with that. I just ask what's parallel to what. So you're fine, okay? Now, in this next one, in 9 through 14, every time I mark someone's stuff wrong on this, they just kind of like went through and answered the question without marking the diagram. Please mark the diagram. Okay, so use the information provided in the directions, mark your diagram over here to your right, and then answer the questions 9 through 14. Go ahead, get those done. Okay, so now we're sitting at a position now that hopefully you've marked up your diagram. And hopefully you read everything. Hey, well, a QR is 30. This whole thing is 30. That means this is 15, so is this. And people are like, how did you find that? Because they told me that M, N, and P are midpoints. Okay? Now, on this next thing, our S is also 30. So cutting that in half, I know this is 15 and that's 15. Now, I've got some people that just went crazy at one time and decided that everything must be and didn't finish reading. Make sure you finish reading all the information. This is 9 and this is 9 because that's what half of 18 is. Now, all I did was find the lengths of half the segments. I got to find my mid segments. And then after I do that, I fill everything in. I'm good. Okay? And some people, I can't believe it. I've seen so many people drop the ball about filling in the right number that they listed or didn't list. They go, well, I don't know what happened. It's like, I don't know either, but I can only grade what you give me, and it was wrong. Make sure you're careful on these. The slam dunks are the scariest ones. Questions on this? Now, method-wise, I know people know the half of a value or a double of a value. I want to get you in a habit to set up the relationship you're using. 2 reasons. 1, I give you points for setting up the relationship in a quiz or test. But more importantly, just to set up, if I don't give you numbers, okay, people have a hard time setting up which one. So if you do the same thing every time, it's good. So in problem 15, I want you thinking 2 times the inside value when it's a midpoint and a midpoint connected. 2 times your X value is equal to 34. Notice how I said that. If I multiply the mid segment by 2, it's equal to the side it is parallel and opposite to. And the reason why I say it that way is because I get to avoid fractions by taking half of the outside. And some people go, well, half of the outside is 17, but what's your deal? It's like, dude, it's still 17. It's just that I'm aware that with numbers, it's nice, slick, fast. But with things like problem 17, go ahead and set it up. Do 17. Don't worry about 16. We'll get to that. Do 17. Okay? People have a tendency to say 17 is something other than the answer it's supposed to be. 2 times the inside value, because 7 is the length of the mid segment, is equal to 2 times x. Okay? Hey, wait a minute. X is 7. Yep, it is. Okay? But notice how I set it up. I teach patterns, okay? I work with patterns. I present properties that are based on patterns. If they weren't patterns, they're not properties anybody discovered, okay? We're still discovering them. It just doesn't seem as many as we're going through, but it's kind of interesting when they do come out with some. But keep in mind, this is all about patterns, okay? Now, let's look at 20. Based on my pattern, take the mid segment times 2. Mid segment times 2 is equal to 35. After I get that set up, I'm in algebra land. Okay? I didn't have to pay $55 to come play in algebra land. It's free. Once you set it up, it's all good. So make sure you distribute to both sides of that quantity inside the parentheses. So I've got 2x minus 16 equal 35. 2x is equal to 51, and x is 25.5. Okay, so that's where I'm going. Algebra land rocks. After you finish 20, go ahead and do 21, 22, 23. I will present those things, those solutions, just like any good restaurant trivia question. Okay, as we do the game, I'll give you a minute on each one. That'll give you enough time to get going on these. We're doing 20, 21, 22, 23. Okay, just to wake you all up. Remember, as you finish, if you're curious about your value, you can plug it back in. Should work. Or you can lean left and right, talk to your row partner, see how they're doing on them. Remember, always the inside times 2 equal 54. 6x equal 54. X equals 9. Oh, I'm even doing the wrong one. Bloom thought he was on 21. There are some days. Again, the inside, 2 times 2x equals x plus 9. 4x equals x plus 9. 3x is equal to 9. X is 3. Okay? Remember, the inside value, the mid-segment value times 2. You got to recognize it's a mid-segment. You got to recognize its connection of a segment's connecting 2 midpoints. Okay? Once I make that connection, I'm going to go, okay, 2 times that mid-segment is equal to the side length of the triangle. It is parallel to. Okay? So keep that in mind. It's the same policy, same pattern each time, same thing. We're working that property, working the pattern. I got 4x is equal to 10x minus 21. I got negative 6x is equal to negative 21. I divide, I get 3.5. Same pattern each time. Okay? The mid-segment times 2 is equal to the line or segment of the side of the triangle it is parallel to. That third side. Okay, the mid-segment connects 2 sides. The third side that isn't connected is the side it is parallel to. That's the side we're worrying about. So set it up. 2 times 3x equals 4x plus 20. And get her going. It's the same thing every time. It doesn't change. I go to the inside number. 3x. 2 times 3x equals 4x plus 20. 6x equals 4x plus 20. 2x after I subtract equals 20. X has got to be 10. As we're getting it through. Okay? Are there questions regarding? Now, flipping the page, look at 24. Keep in mind, we're working with the idea that this mid-segment and the side it is opposite are parallel. Okay? What do you remember about parallel lines with a transversal in angles? Remember alternate interiors, alternate exteriors, same side, corresponding? It's all back. I just got to know which one to use. And people are like, what? This is parallel to this. I've got a transversal. This is 70, and they're corresponding angles. So I got BDE is 70 degrees. Not because I felt like it, not because it looked like it, because I have a property of 2 parallel lines cut by a transversal. Okay, and that transversal sandwiches the angle 70 degrees in there as we go. So I know BDE, if I get rid of this now, I know BDE is 70 because A is 70. Okay, because those are mid-segments. They tell me that in the directions. That's why it's important to read these things. Don't make assumptions. Make sure you're reading it. Make sure you're marking up your diagrams. Last thing. Last 2 things, I should say. This is the beginning of the end right here. I want you to plot L, M, and N. Plot L, M, and N. L, negative 4. 1, 2, 3, 4. 1, 2. So L is negative 4, 2. M is 2, 5. 2, 1, 2, 3, 4, 5. M is 2, 5. N is 4, 3. 1, 2, 3, 4. 1, 2, 3. N is 4, negative 3. So I've got this mid-segment triangle. And people are like, what do you mean mid-segment triangle? It's a triangle made up between the midpoints of the sides. Okay? Now, in my head, I'm thinking about the solution of this. Okay? I'm doing a quick sketch off the grid because I want you to see what I'm thinking. They're asking me, what are the coordinates of the vertices of the triangle? How do I go about that? So I'm going to just kind of diagram the process that I'm going to use. Okay, but the first thing you have to recognize is that parallel lines have the same slope. Okay, now I'm going to use that idea, and the reason being is this. I've got a mid-segment. Okay, these are two midpoints connected. That's mid-segment. There is a side of the triangle that is the same length forward and back of the midpoint of the side opposite the mid-segment I have. If I use rise, run, I go rise, run, I have that same rise, run, maybe I went a little happy on the length there, and that same rise, run, that's my rise, my run, my rise, and my run. And when I apply that rise and run twice, once on either side of the provided midpoint, I get the full length of the side that it's the midpoint of. Okay? So now, what I want you to recognize is I've got this side based on the information provided. And then, based on this other stuff, I know this segment's slope. I'll be able to finish off this slope going through. Okay, and I'll be able to finish off this slope going through, and I will have the endpoints, the vertices of the triangle, of the original triangle, just knowing the midpoints of the triangle sides, okay, based on slope. And that's all I'm doing. So in my head, I have this mid-segment triangle going on, and I'm going to construct this one to find those vertices. And it's all about counting. Okay, so let's go back to that original triangle for a second. Okay, I'm going to get rid of my dots, my dotted lines there. And I'm going to talk about the fact that my first one, I'm going to talk about this slope. It's 1, 2, 3, 1, 2, 3, 4, 5, 6. 3, 6. Do not reduce it because I'm going to go to the side opposite it and go 1, 2, 3, 1, 2, 3, 4, 5, 6. And that's one endpoint of my side. Okay, my others, down 3, back 6. It's my other endpoint. So I have the point -2, -6. 1, 2, 3, 4, 5, 6. Yep, -2, -6. And I have the point 8, 0, I think it is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10, 0. So I already have 2 points out of 3 for my triangle, based on that one move. Okay, so now I can connect that. That's the outside of my triangle. It is one side of my triangle. The others are based on the slope. So I'm going to go off to this one to this midpoint. Okay, I'm going to go up to this one to this midpoint, and it's going to be for this one coming across here. So I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8 over 2. 1, 2, 3, 4, 5, 6, 7, 8 over 2. Crazy, it's right there. That's where it was, right there. That is my mid-segment. This is the side parallel to it. Now I do 8 up to the left. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2. And I have, that is my other side of my triangle. Okay? Now what's really cool about this second one is I have my other answer right there. 1, 2, 3, 4, 5, 6, I think it is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 6, 10. -6, +10. My vertices. Now I'm just going to double check. This last one I haven't used red. This is my mid-segment. It has a slope count going down 1, 2, 3, 4, 5 over 1, 2, 3, 4, 5, 6, 7, 8. So I got a slope count to over here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. Hey, it's in the right spot. So I can do it over here. Back 8, up 5. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. My last one comes in there. I've checked my work. I've gone over. All I did was just apply slope. Now I got a second example. We're going to do that right away tomorrow because I know some people are like, boom, what did you just do? I just did slope. And I'm going to do it very methodical for you tomorrow. I just let you see big picture. Tomorrow we're going to chop it up, do one at a time. Okay, so now we're done with notes. Oh, one other thing. Let me give you your assignment real quick. I want to talk about problem 24. 28, I lied, not 24. So let's look at 24. I think I got the 0.03 and the 0.60. You're supposed to draw a line through or write an equation on. This is 28. You got, I think, point A, 0.3, point B, 60. You must find slope. y2 minus y1, x2 minus x1. You got to find slope. So you got 3, 0, 6, 0, 6. Find their difference. You got 3, negative 6, which is just negative 1/2. Okay. Now, here's the thing. I have two choices to find my next step, but both of them revolve around the fact I'm using point slope form. So point slope form. Y minus y1 equals mx minus x1. And now I've got 1. I don't care which point you choose. I don't. You just got to pick one of them. So I'm looking at 0.3, so 3 is there. Negative 1/2 for slope. X is 0. And I'm done. I just wrote my answer. Now I've got some people going, what if you pick the other one? Well, if I pick that. Y minus 0, because 0 is the y. X minus 6. Okay, just to make sure you remember what's going on in that section, I just wrote it in point slope form. If you solve for y, you're in the slope intercept form. Okay, and it's a little review, all right, for what's happening. Next thing I'm going to do is hand back your test. For those folks at home, you can't get yours because you're not here. Nah, 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 nah. Okay, hope things are going well. Make sure you're focused on getting things done. You've got less than 4 weeks now, because today's done, to go to break.